Now let's talk about select. Okay, so selection operation is generally used to choose a subset of tuples. I'll just take an example and explain you. See, if we have a table, if you have a relation, right, like this, generally you have many columns. Selection is used to choose some of the tuples like this, right? So you can think of select as if we are selecting some of the tuples, right? And sometimes it is also called as horizontal partition. Terminology is important. Okay. It is horizontal partition. So what is horizontal partitioning is we are dividing the table into two parts, right? And how to do this, we specify a condition, and generally we use the symbol sigma to represent a select query, right? And we use some condition. For example, assume that this is employee table, okay, and this is employee number, and this is employee name, and say this is department number to which the employee belongs to. Now if you want to choose, or if you want to select, let's use the term select only, okay? If you want to select all the employees who belong to department number 4, then I can write it like this: select department number equal to 4 from where? From this relation, right? EMP. So EMP is the name of the relation, right? Now see this internal thing can either be a direct table, or it can even be a relational algebra expression which will result in a table, right? Which means on a table we can again select some of the rows. So we shall see that later. For now, just see this, and let us say there is one more column which is having, say, salary. And if you want to find out set of all employees who are having salary more than 10,000, then we can say that salary greater than 10,000 from employee. Alright, then those particular will be selected. Now if you want to know who are all the employees who are present in maybe department number 4 and who have salary greater than 1,000, right? Then what you can do is you can either first apply this and get a table, and on that you can apply this. See, what I mean to say is like this: select, first you can select, okay, let's do it internally, okay? So first I want to do this. Let's say we have selected all the employees who are having salary more than 10,000. Now from those rows also I can filter out. I can filter out only the employees who belong to department number 4. So select is in some sense acting as a filter, right? So what is a filter? Which means it is trying to remove some of the tuples and retain some of the tuples, right? So here in this query, you might think that you can even apply this department number inside and this one inside, which means you might think that I could have first find out all the employees who belong to department number 4 by using this, right? And then out of those you can select all the employees whose salary is greater than 10,000. Even this is also going to give the same result as this. So if you observe this, whenever you have two select conditions, right, you can apply anything inside and anything outside. Therefore it is very important to note this: select is commutative, right? And even you can cascade them all. You can even cascade them like this: these two queries are also equal to this query, right? So the query is salary greater than 100, and you can write this relational logical and the AND operation, right? Boolean and department number equal to 4 from employee. So you can even write like this, right? So remember this, the most important point is it is commutative, which means we can change the order in which these operations are applied, and also you can cascade them like this, right? Anyway it is going to be same. So one thing you should also remember is we filter out only some of the rows, but all the columns will be present. If the given table has four columns, then after the select also we get all the 4 columns. The number of columns doesn't change, only the number of rows change, right? So if you have a relation R, right, and let us say mod R represent number of tuples on the relation, then if you apply some condition on that relation or select condition, right, and you get a new relation, and let us say this represents the number of tuples in the new relation, what will be the relationship between these two? It will be, this one will always have greater than or equal to, which means by filtering some of the rows we don't get more rows, isn't it? So we might get less rows, right? Then what is the maximum number that we could get here, and what is the minimum number that would get here? So whatever is present in this, that is the maximum, isn't it? So sometimes if when you apply a condition, everyone might satisfy it, and therefore you might get a maximum of everything. And what will be minimum? No one might satisfy it, then you get minimum of it. 0, minimum is 0, right? For example, in this query, let us say you are trying to find out all the employees who are having salary greater than 10,000. If all the employees have salary more than 10,000, then the output is going to be greater than 10,000, isn't it? And if you want to find out, let us say all the employees who have salary greater than 20,000, let us say there is no employee with salary 20,000, then we get 0, right? This cardinality is also important. Some questions were asked on this, and questions will be asked on this, okay? And one important thing is select works only on one tuple at a time. So you cannot say that select 2 tuples at the same time, right? You can at any time while processing it, you are going to apply this select on only one tuple at a time, okay? And when we have to work on more than one tuple at the same time, then we might have to use something else. So later I'll show you how the cross product is going to work, okay? And in general, this the syntax is like this. Select is represented by sigma, and here we have selection condition, right? And here we have the relation. And now this is called sigma, and this is a selection condition, and here R can be any relational algebra expression. What is a relational algebra expression? It is again a combination of many relational algebra operations. A relational algebra expression is a combination of many relational algebra operations, right? And this selection condition is generally, it can be written like this. It is any combination of Boolean algebra expressions, right? So it is a Boolean expression, and we know that Boolean expression will contain at least one condition, and that condition will be of form generally attribute name, and then comparison operation, and then some constant, right? Or we can even compare 2 attributes, attribute name and then comparison operation and then attribute name, right? So both are allowed. So you can either compare an attribute with a constant, or you can compare attribute with other attributes. Here we have compared attribute with a constant, right? You can even compare 2 attributes given that both of them have the same domain. Let us say here there is one more attribute called as maybe manager number, and if manager number and employee number are having the same type of attributes, then domain, the numbers, then you can compare both of them. That is also meaningful, okay? And so what happens is sometimes instead of having one condition, you can have many conditions with a logical expression, Boolean expression like this, right? So here we have many conditions and they are actually logically combined, and we got a Boolean expression. Got it? So this is how select works, right?